So we're connecting right now with the Nautilus Ocean Expedition, and we will learn a bit more about their everyday life and also about the main tasks that they are doing and their scientific motivation and what's the mission and what are the biggest milestones so far of the mission, and also how we can see the connection in between this type of exploration and also space exploration expeditions that we plan and that we are focusing on during our event. We could also, if we have enough time, we will briefly describe the careers and the profiles that are needed both in this type of expeditions and in the oceans explorations expedition, and also talk about skills that can be transferable to the space exploration.
Oh, can you hear us now?
Yeah, we can hear you very well. So welcome, Martina, and welcome, Yashira. Good to see you. Hello.
Good to see you as well.
So could you tell us a bit more about your roles and during the expedition?
Yeah, of course. My name is Dashira Cruz. I am a communications lead here on board of the exploration vessel Nautilus. So my role is basically coordinating all of the outreach efforts that go out to the public from the vessel. And I'm also collaborating with a set of amazing STEM-focused educators who also produce a series of educational products that go out to our website, nautiluslife.org.
Yes, and my name is Martina Graban. I am Chief Officer on board Nautilus. I'm very excited that we can meet on event in Kielce, in Poland, from the middle of Pacific Ocean. And I hope you will enjoy our short presentation about our ship, exploration, and the new technology that we use on board, which is pretty amazing.
Yeah, we're looking forward. So go ahead.
Amazing. All right. So, like we were talking about before, we are connecting to you directly from the exploration vessel Nautilus, which is currently transiting out of Papahanaumokuakea Marine National Monument in the Hawaiian archipelago. And we're heading back to port after a 25-day expedition mapping the seafloor. And that's actually our first step in the ocean exploration process. We actually lay a map of the seafloor before deploying our remotely operated vehicles to break the barriers in the areas of chemistry, biology, geology, maritime history, and outreach and education.
So how many of you is there?
Yeah, so
for now we have 45 persons on board. Maximum capacity that we can carry is 52, all scientists and crew, ship's crew.
So can you tell us a bit about your everyday life? How does it look like? You have some shifts, I guess, and you have to carry out scientific tasks, right? Like our rovers, Mars rovers do here also during the competition. So how your days look like?
Yeah, for the education and outreach team, a big component of what we do is transmitting live interactions from here in the studio. And we also gather in our control van to talk about the operations going on here on the ship. So any given day, we can have anywhere between 2 to 10 live interactions with audiences from all over the planet. And then Martina has a more technical aspect to her work.
Yes, I work on the ship's bridge, and we have 3 navigational officers. We keep 4 hours watch, so my watch is from 4 to 8 in the morning and in the evening. And during that time, we drive the ship. And of course, afterwards, we have some additional tasks on deck and a lot of different.
So what time is there now? The local time that you experience?
Right now it's 12:20 a.m. So we're just starting our day.
Yeah. So, and could you tell us a bit more about the milestones of or discoveries that you made?
Yeah, I would love to tell you more about our technology, if it's okay, and how we have been working with different organizations to integrate robotics into ocean exploration operations, if it's okay. So, our remotely operated vehicles, Hercules and Argus, are equipped to go up to 12,000 feet or 4,000 meters in the seafloor, and they operate in environments that are pretty extreme, sometimes unpredictable, but ripe with possibility when it comes to discovery. And so they need to be programmed and built in such a way that they can operate in these highly dynamic environments, which highly mimics a lot of what goes on in space exploration. In this case, we're working with really high temperatures sometimes, or very low temperatures. And very often we're working at high pressure. And Argus, which you'll see right here, is often connected to Hercules. So they work in tandem. So while Hercules is our main workhorse, Argus is keeping a watchful eye, and it works like a video sled. So what it does is keep track of the movement of Hercules in this dynamic environment to make sure that our operations are effective and that they are safe, because these are highly specialized and unique robots, right? And this is something of what it would look like when we're exploring in cave-like environments. The seafloor is not flat. Sometimes it's cavernous. There are canyons. Sometimes we're exploring hydrothermal vents. And so it's necessary for us to have a lot of situational awareness of what is happening throughout our expedition. And all of this is streamed live through our website, through a process known as telepresence. So Nautilus is going to be on the surface. The ROVs are going to be connected to it through a tether. And the tether has fiber optic cable. So as Hercules is collecting information about these hydrothermal vents, it's sending that information back to Argus, and then it goes back to our ship, where it's transmitted from our dome out to space. Go figure. So we are connected to space somehow. And then all of that information goes to a satellite substation and back to the inner space center. And that process also allows us to conduct tele-exploration. So not only the crew and the scientists who are here on board get to participate in the science, but we also have people at home. So just lay audiences joining us and enjoying the process and asking their questions live. But we also have a Scientist Ashore program where they are able to share their knowledge with us as we're exploring these unknown environments. But they're also asking us for certain samples so that way they can be made available to the wider scientific community in the future. And I have actually Kim Weaver and Shannon Donovan here with me. They're two wonderful STEM educators, and they would love to jump into the conversation and talk to us about different robotic systems that have been integrated into our exploration activities throughout the year.
Sure. I'll jump in first. My name is Shannon Donovan. I'm a Science Communication Fellow on board this mapping cruise. And I was also on board in 2018 when we were doing an expedition in collaboration with Ocean Networks Canada. One of the amazing accomplishments of ONC is the installation of a wired ocean observatory that you see here in this image. And one component of this observatory is actually a benthic crawler named Wally. And Wally is wired into this network and actually controlled by folks in Germany. So as opposed to an ROV, we could consider this an IOV, an internet operated vehicle. And so there's a little bit of latency in that operation. This robot can stay on the seafloor for extended periods of time and observe changes in the environment, longitudinally. So provides some really great opportunities for observations.
And hello, my name is Kim Weaver. I am a science communication fellow here on board the EV Nautilus. My background is in civil and environmental engineering, but I'm also privileged to work with NASA on some educational materials. And one of the things that I am really excited about is the Nereid Under Ice Vehicle, otherwise known as NUI. And this vehicle has been on Nautilus several times, integrated with our systems, and then going on deployments and expeditions. What's special about NUI is that it communicates via an optical modem. And so what you're seeing is Argus communicating via light with NUI, and then NUI sending data back. This is kind of similar to the Mars rovers that are able to operate both remotely operated or somewhat autonomously operated. And so that's an interesting thing about NUI, is that it's an ROV and an AUV in one. And another interesting thing is that a couple of years ago, we had NUI on board, and Woods Hole scientists in Massachusetts took control of NUI and controlled NUI from Massachusetts when we were out in the middle of the Pacific. And one thing that was really interesting about that is that the signal latency between Woods Hole, Massachusetts, then beaming up to our satellite and down to the ship, and then down to the optical modem, is really similar to what NASA scientists will experience with the Viper mission to the moon. This is a remotely operated vehicle that will be on the moon in a few years, hopefully. And scientists will be operating it from Earth with a signal latency of about 2 seconds. And so missions like NUI help us to rehearse for that level of signal latency.
All right. Thank you so much to both of you for joining us here today and sharing all that knowledge with us. As we're going about all of those technical operations, it is very important to rely on a team of people who are very clear about their role and the mission objective. So as we're going about our operations, generally, there are several people in this room, the control van where Shannon and Kim are joining us from. So generally, we have a total of around 7 roles, including a science communication seat. We have our ROV pilots, navigators, and scientists who are all collaborating with also people on shore, and of course, with Martina up in the bridge. So Martina, I would love you to jump in right now and tell us about that process.
Yes, sure. So as we said before, on Nautilus can be up to 52 persons on board at sea one time. And we have crew changes every 2 or 3 weeks. So there are a lot of people coming in and out with different backgrounds, hobbies, education, and it's that's one of the most amazing part of working on Nautilus, to spend time on the small ship with so many interesting, amazing people. But the ship's crew is a group of 17 persons, and that's professional mariners. And basically our main job is to drive the ship from the bridge and from the NG control room. So during the expedition, we have to make sure that we keep the ship in safety manner, following all the regulations, following a good seamanship practice, and of course the requests from the scientist team.
Yes, and as we're taking care of those operations, we've gotten a really great opportunity to collaborate with the space community here in the United States. And a really exciting opportunity that we had in 2018 was to come to Papahanaumokuakea Marine National Monument and collaborate with the Jet Propulsion Lab. And we were testing this mechanism known as the Gecko Gripper. And this robotic arm is equipped with a series of nano hairs that allow it to attach to different irregular surfaces, such as this basaltic rock. So in this case, we're trying to operate it at really high depths, high pressure environments, and with a neutrally buoyant remotely operated vehicle. But something really exciting about this technology is that the tiny little hairs that are inspired by van der Waals forces created by gecko feet can also be applied to other environments out in space under microgravity. So the idea is to take it to environments in space and help stabilize certain things. So it's essentially like a robotic Velcro that can be used in these environments. And just like this, we've also collaborated with NASA and NOAA and a mission called Subsea. So we're focusing on studying biogeological aspects of hydrothermal vents with the idea of looking at the parallels between the remote exploration activities that are bound to happen in space exploration and in ocean exploration in these extreme environments. So what is it gonna look like to have a team kind of distributed all throughout different areas and also have these robots on site? And this is an example of some of our activities in the mid-Pacific Ocean. So in this case, we were exploring hydrothermal vents and microbial growth in these extremophile environments. So all the yellow that you're seeing in this picture is actually microorganisms that are growing right there. It's life happening in these very, very extreme environments. And just like that, we were also able to mimic this type of operation off of the coast of the west coast of North America. And here you can see close to the Apollo vents, which were recently discovered in the last 2 years, how Hercules is able to then take direct samples of seepage that's coming out of these hydrothermal vents, which really, really high temperatures. So it's truly fascinating to see the coordination come to a development as we explore these really extreme environments and seeing what's possible in this front. There's definitely a lot of possibility in the future, but we're very proud of the work that has been done here so far.
It seems that there is a big actually overlap and connection in between what you do and space exploration, and especially the missions that you mentioned already. So it seems that maybe actually we can train future space engineers or space engineers itself on a board as you could do. So could you comment on that? If there are like any special skills that basically you develop that we can transfer to the field of skills of space engineers or people working in space or?
Yeah, I think there are a lot of possibilities in terms of navigational abilities. We have a lot of software engineers and data engineers. As we develop any kinds of science, it's really important for people to understand how to go about managing all the information that's being gathered, right? There are many sorts of engineering, and because the environments are very similar, engineers can then be able to transfer those skills between space exploration and ocean exploration. We also need biologists, let's say, if at some point we find life in other planets, to identify that. And of course, we need communicators to make sure that all of that science is being brought out to the world and that we're inspiring the next generation of explorers.
Yeah, so this is actually what we very often do, talking about space and the universe. So I find it really fascinating that we can actually meet so many connections in deep sea exploration and space exploration. So since we have some people here in the audience, may I use this time for asking if there is maybe any question that someone would like to ask. So I already see a hand, so let me just... would you like to come to the stage, or I can? Yeah.
Perfect. Thank you so much first for the very interesting talk. It's really great to see you from here. I just have a small question, which is I'm wondering if something breaks on board, what is your strategy today? Do you have to go back to port if you don't have a spare? And maybe connected to this question, I am wondering if you think that having a 3D printer on board would be something useful. Thank you very much.
Yeah, thank you. That's an amazing question. Martina, you want to jump on it from your perspective, and then maybe I can give my own perspective?
We always try to repair everything on board as far as it's possible. Usually we have exploration expedition far away from the shore. Actually, this cruise we were doing exploration like around 600 nautical miles from the shore. So it would be very last thing that we decide to come back to port for the repairs. But of course, we always bear in mind that it might be this situation that we have to come back, but it would be the last moment, especially when we do the research so far from the shore.
Yeah, and then from the scientific operations perspective, we do have an ROV hangar here on board. So basically, this is a space like your garage at home where we have a whole lot of spare parts because things break all the time. That's the reality. After each dive, our engineers are actively going out and going through a checklist to make sure that the ROV is functioning appropriately, but there are parts that are replaced overall. And then I know that Shannon has a lot of experience with 3D printing, and I would love to have them give their perspective on how valuable it could be to have that tool on board.
Sure. And I understand that there has been a 3D printer on board at times in the last couple of seasons. And so we are exploring that as an option to deal with situations where a need arises. You know, the conditions we're working in under very high pressure are challenging. And so that's going to require some different materials, more robust materials than we typically see in a 3D printer, but those technologies are being developed. We have 3D printers now that we can print in metal and ceramics, and so those options are opening up, and we'll, I think, continue to see exploration incorporating those tools.
Thank you, Shannon. And thank you for your wonderful question. That was great.
So do we have any more questions? Someone would like to ask something? So, yeah, we have one.
So hello, thank you very much for this super rare opportunity to talk to people who are doing marine biology. I'm a marine microbiologist as well and an astrobiologist, so I'm very happy to see you. Yeah. I wanted to know if there are concrete plans to use some of the beautiful rovers and like NUI and like the others. Are there concrete plans to put them in JPL into sort of like, you know, other worlds, other ocean worlds? Scenarios? Is that down on the timeline for these things?
So I believe that for our robots, we are focusing on our own ocean because there is so much we don't know yet of our world's ocean, right? We've seen very little of it with our own eyes, and we've only mapped around 23.4%. And without the maps, we don't even deploy the robots. So at this moment, when it comes to with regards to our own robots, the plans are to focus more on our ocean. But I think that the ties that are being created for us to allow our instruments to serve the space community for their own testing are going to keep growing over time for sure. And this subsea expedition has happened twice. So there might be future plans for that to happen in the future as well, although I'm not clear on when that might be.
Great, thank you very much.
Okay, we have one more. Sorry.
Hi. While cooperating with NASA, you are a private organization. NASA is a public institution. Did they actually approach you? Did NASA scientists approach you to take this opportunity, or were you approaching them to present the potential? So, what was the way of starting this collaboration?
Yeah, I honestly am not aware of the logistics that were happening behind that expedition, as I was not, unfortunately, personally involved. But we are a nonprofit organization, and we receive federal funding to explore the waters within the United States exclusive economic zone in different areas of the world. So it would make sense that our operations would be aligning with NASA's in some occasions.
So we were actually experiencing some water during this year competition, European Rover Challenge, since it was raining a bit. So the rovers that were designed by the team that compete here had to deal with much more water than they expected. So I believe also the robotics and that you are testing would be the outcomes of that will be very useful for maybe future editions of European Rover Challenge. But anyway, since we have some students here, students working mostly on the rovers and so on, but what happens if someone is interested into joining the expeditions, the one, for example, that you are? Is it possible? Can someone apply?
Yeah.
What kind of person should that be in a sense of the skills, and how it's possible to stay connected?
Yeah, so we have a robust internship program for undergraduate students, and we actually recently opened our applications for our engineering and ocean sciences program. So I'm loading the page right now so I can show you. So if you go to nautiluslive.org/education, so this is our page where we have all of our educational opportunities. And if you go to students, you'll be able to find the science and engineering internship program. And I would imagine that the bulk of your students that you serve would be interested in the engineering position. Engineering is an amazing opportunity. So when students come out, they get to train side by side our ROV pilots. So during our live operations, they sit down and they learn to pilot the remotely operated vehicles as they're down in the ocean. And something that they also learn to do is to work with those more mechanical aspects. So they're actively participating with the team to learn the skills necessary to come back, hopefully not only as interns, but as professional engineers, and keep bringing those newfound skills to the future of their careers.
That's really awesome. Thank you. So actually, we were discussing also a bit before in terms of space, working in a space sector, a gender balance and all the things related to that. Could you comment on it? Because we see quite many women working during your expedition.
Yeah, so Ocean Exploration Trust does aim to have a wide representation when it comes to identities, genders, and different nationalities. And our core is almost 50-50 when it comes to women versus male. And we're also trying to represent non-binary folk as well, and trying to do a better job at that. So that way our ocean exploration core also represents the population of the world, right?
Yeah, so and cheers to the person in the back, just like who was waving to us. I don't know.
Yeah, they're celebrating over there.
Hello. So just maybe because we are running out of time, any more questions from the audience? And if not, oh, okay, we have one more. So just sum up in a moment.
Hello. Yeah, I just wanted to ask, like, how is the operation controlled by internet? There was like a topic that was talked about. Could you explain more how it is, like, the operation is carried on?
Yeah.
I think asking about Wally, right?
Yes, yes.
Yes, so Wally is plugged into one of the nodes that sits on the seafloor. It's kind of like a giant underwater power strip with an Ethernet connection. So it goes to shore and then out to the towers and connects by internet over to a lab in Germany that controls it. I am not part of that team, so I can't really speak more to the details, but that's as I understand it.
So as
Thank you so much for your questions.
thank you. As an experienced person that works in expeditions and exploring the unexplored, could you, to sum up, just give any advice to people that are here, especially to those who work on rover, on space explorations, who are like kind of starting their career? Is there anything you would like to add from your perspective? Any advice? We'll be really happy to listen.
Of course, we can go around the room. Martina, do you want to do the honors?
Yes, I think that the biggest advice is just to keep going, keep exploring, never give up, because there are so many opportunities. So yeah, have your eyes open and keep going.
Yeah, and my advice would go very much in line with that. It's just look for any and every single opportunity to learn new skills and to apply those skills, even if you don't feel 100% qualified to do it. Because as you're throwing yourself into that experience, you're gonna be growing those skills and developing them to then also grow into that position. And now I'm gonna throw it back into the control van for Kim and Shannon.
Yeah, thanks so much. My advice is no matter what your specialty or career is, make sure you are communicating with and connecting with people who study other things and who are working outside your field. The most interesting thing about being on the Nautilus is that we all have different specialties. And so don't get so insulated in your one specialty that you only talk to other people who study that. Make sure you are seeking out. If you're a geologist, talk to the biologist. If you're a roboticist, talk to the data person. Really, really make sure that your network represents everyone who's involved in exploration.
Yeah, and I would just piggyback on that. Don't be afraid to change directions. And make sure you're asking questions of people who are different from you, because they bring different experiences and different ideas to the situation.
I believe that it was really a fruitful and fantastic sum up of our meeting. So unfortunately, we are running out of time. It would be lovely to talk to you a bit longer. But I guess you have your stuff to be done as well. We have to keep going with our rover ERC 2022 event. Thank you very much for the connections. Thank you for your time. Thank you for a very fruitful discussion and presentation, and it was lovely to have you here during ERC 2022. Thank you.
Thank you so much for the time. Thank you for having us. And just want to share our handles. Follow us on nautiluslive.org. All of our highlights and our operations are streaming live 24/7, so you can keep following along. Thank you so much.
Thank you, and good luck in discovering the undiscovered.